Good afternoon, grade 12s. Welcome to mathematics. We are going to be doing paper 2 revision. As you know that we'll be writing paper 2 next week on the 15th of December due to what happened of the previous question paper that we wrote on the 16th of last month. Now, before we can start with our revision, I just want to advise all the grade 12s who are doing mathematics or who are going to be writing this paper that please let us make sure that we are using the previous question papers to prepare ourselves very well. And then we also have to have the examination guideline for mathematics and just go through that document. It's a very important document to have. And then in that document, you'll find all the topics that we are doing under mathematics. And then particularly you only focus on the topic for paper 2, you just go through them and then look what are they saying about those topics. Especially there is this topic of Euclidean geometry where they give us the acceptable reason that we should apply when we are answering question under Euclidean geometry. It's very, very important document. All right. Let me just let's start with our revision and see what are we going to be discussing. Like I was saying that we are going to be only doing on revision for paper 2, and then before I just try to give you the picture of paper 2 or the structure of paper 2, and then even the weightings of each topic that falls in paper 2. We can start with statistics, which is contributing 20 plus or minus 3 marks. We then go to analytical geometry, which contribute 40 plus or minus 3. And the third topic is trigonometry, which is also contributing 40 plus or minus 3. Of course, the last topic, which is Euclidean geometry, it contributes 50 plus or minus 3 marks. So these are 4 topics that form part of what? Paper 2. So today we are only going to be talking about analytical geometry. We are going to be answering questions under analytical geometry. But what is going to happen? We are going to start with the question paper which was written last year, 2019, November. We are going to be discussing questions under analytical geometry. We then move to a question paper of 2020 that it was written last month on the 16th. Then we just compare and then try to answer all those questions and see if maybe there are similarities or maybe are things that we need to make sure that before we go and write next week's paper, we prepare what is needed. All right. Now let's start with the analytical geometry. Or under analytical geometry, there are a formula that we normally use when we are answering questions under analytical geometry. As you can see on the screen, that I have tried to give all those formulas that we used under analytical geometry. And then the fortunate part of this topic or this question paper is that all these topics, you will find them at the back of the question paper. So there's no need for you to memorize this formula. But what is important is that you should be able to know when to use each formula and how to use it. It's very, very important. But I'm going to just to talk about this formula before we can start with our question papers. Now, if we can look at the first formula there, this one we normally use when we are calculating the distance between the 2 points, the distance formula. And then this one is when you are calculating the midpoint. For instance, if they say to you calculate the midpoint of AB, is the formula that's supposed to be used. And then this one is when you are calculating the gradient of from the gradient of of 2 points. All right, when you're having 2 points and then they ask you to calculate the gradient, there's the formula to use. And the other thing that I want to emphasize on this one is the issue of how do you write this formula. You can see on this one we said yb minus ya. So once you have started with yb, you should also start with xb here. Don't say xa because you are not going to get it right. And then you can also start with ya, does not matter, but make sure whatever that you have started with here, you should also start it with under denominator here. All right, and then we go to this one. This is the standard formula for the equation of a straight line, where m is the gradient, and then we know that y1 and x1 stand for any point that is going to be used to calculate or to determine the equation of a straight line. And we also have that one of y equals to mx plus c. And then we come to this one, is when we are calculating the angle of inclination, and then it says tan theta equals to the gradient of AB. All right, for you to be able to calculate that angle, it means you are going to be in need of what? Of the gradient of that line where you find the angle. And then this one is when we're having two lines which are perpendicular to each other. For instance, AB is perpendicular to CD, meaning if that is the case, it tells us that the gradient of AB multiplied by the gradient of CD is equals to -1. So every time when you come across two lines and those two lines, they are perpendicular to each other, you must know that the product of the gradient, they are equals to -1. And then we come to this one. Just ignore this one. Just ignore this one. And then we say when we're having what? If AB is parallel to CD, meaning when we're having two lines which are parallel to each other, then you must know that the gradient of the first line, which is AB, is equals to the gradient of the second line, which is CD. Right? And then the last part is when these are the standard equation of circle. And the first one is x squared plus y squared equals to r squared. It's when a circle is centered at origin. And then the second one is when the circle is not centered at origin. All right, so these are the formula that we normally use when we're calculating or determining the equation of a circle. All right, let's proceed. Okay, now we are starting looking at that paper of 2019 November, question 3, because analytical geometry is that in question 3. And then let's see what was the question, and then let's see how best can we answer that question. All right, it says in the diagram, P R 3 is to 5, S is -3 is to -7, and T is -5 is to K are vertices of trapezium PRST, and then PT is parallel to RS. Right? Remember earlier on I talked about the parallel. When we're having the parallel lines, what you should know about the parallel lines. Then RS and PR cast the y-axis at D, and C is O is to 5, 0 is to 5 respectively. PT and RS cuts axis at E and F respectively. P angle EF equals to theta. You can see that this is theta there. Now let's see what are the questions we should answer. The first question says write down the equation of what? PR. Let us look at PR. You can see PR. PR. You can see PR. PR. See, this is PR. Then we need to calculate the equation of PR. All right, let's see what is the solution for this one, 3.1. they are saying is y equals to 5. Why? Because when you look at this line, is parallel to the x-axis. All right, so when we have to remember, when we have to calculate or determine, in fact, when we have to determine the equation of a straight line, which is PR, you are going to be in need of what? Of the gradient and a point, right? But now when you calculate the gradient of this line, you can use this point C as well as this point R, because we've got the coordinates. Your gradient is going to be what? Your gradient is going to be 0 there. And then remember the standard equation of a straight line is y equals to mx. Let me just try to write mx plus what? Plus c. All right. And then if the gradient is going to be 0 there, then surely this x is going to disappear. Then we're going to be left with c. And then what is this c? You know that c is what? Is the y-intercept. It's y-intercept. And then you can see that we are given y-intercept as 5 there. As 5 there. Hence, now the equation of that line PR is y equals to 5, because we don't have what? We don't have the value of what? We don't have x, because the gradient was what? It was 0 there. And then 3.2, calculate the gradient of RS. Calculate the gradient of RS. Where is RS? This is R, and then this is S. Now we just have to calculate the gradient. You write the correct formula for the gradient, you then substitute the values correctly, and then you press your calculator. Then the gradient of RS equals to 2. Then 3.2.2, the size of what? The size of this angle theta. Now this angle theta there. Now remember, when we're in need of this angle of inclination, what do we need? We need the gradient of where we find that angle, the gradient of this line, which is PT, right? But now there is a problem. And you can see that we don't have the coordinate of P. We don't even have a y value on this coordinate of T. Then it's not possible for us to calculate what? To calculate the gradient of this line PT. But now remember, from the scenario, we're given that PT is what? Is parallel to RS. And then you should remember, what does it mean when the two lines are parallel? What do we need to know? You can see from the scenario, the solution, they are saying the gradient of RS equals to the gradient of PT, because PT is parallel to RS. Then the previous answer, we remember we determined the gradient of RS, which was 2. Therefore, the gradient of PT is also equals to 2. Then when we have the gradient, then we say tan theta equals to the gradient of what? Of PT, which is equals to 2 as well. Therefore, we then press our calculator and say shift tan 2, it gives us what? 63,43 degrees. All right. Then in terms of how many numbers we should write after comma, it will depend on the instruction from the question paper. Remember, every question paper does have the instructions where they indicate how many digits we should write after comma. So it's very, very important to follow that, unless it's otherwise stated. Unless a question, it has its own instruction of how many numbers we should write after comma. Is very, very important. And then 3.2.3, coordinate of D. The coordinate of D. Then when you look at this point D, you can see that is y-intercept. All right, that is y-intercept. Now, it means for us to be able to calculate the coordinate of D, then we need the equation of that line, of that straight line, which is RS. Now, do we have that? We first have to determine the equation of RS. Now, let's see. Now, this is the equation of what? Of RS. Remember, when we have to calculate the equation of RS, what you need? You need the gradient, and then remember we have already determined the gradient, which is equals to 2. And then we also need a point. So you can take any point, you can take point R or you can take point S to determine the equation. Then it's going to give us the equation as y equals to 2x minus 1. Then after having the equation of that line, since this point D is what is y-intercept, then we say D is y-intercept. Then when you are in need of y-intercept, you let x equals to 0. Then where you see x, you just put 0. Then it's going to give us y equals to -1. Therefore, the coordinate of D is 0 is to -1. Alright, so we have answered everything. Let's continue. Alright, the question 3 of paper 2 2019 still continue, still heavy. Same scenario, the same diagram. Now we have another new questions. 3.3. If it is given that the TS is equals to 2 is equal to 5, calculate the value of K. Then you can see that we are given the distance of TS. Then they say we should now calculate what? The value of K. Now let's see how best can we do that. The under solution, we then start with the distance. Since we are given the distance, surely we are going to be using the distance method to calculate the value of what? K. And then from there, the second step, you then substitute the values. TS, remember, is given, is 2 is equal to 5. Therefore, then xt minus xs, xy minus xy, yt minus ys, all squared. And then just substitute the values. In the first step, what we did here, we squared both sides to get rid of the square root. And then this is what is going to be, we're going to obtain. Then the fourth step, what we do, we need to transpose this 4 that side. Then it's going to be 20 minus 4. Then it's going to give us 16. And then now, since we're in need of k, then we need to get rid of this squared. Then is when you square both sides, put square root both sides. Then once you put square root both sides, then remember this side is going to be plus or minus. Then with this side, we are left with k plus 7 equals to plus or minus 4, because square root of 16 is equals to 4. Therefore, what we do, we're going to say k plus 7 equals to -4. And then when you transpose that 7, that side is going to be -4 minus 7. It's going to give us what? -11. Then the other one is k plus 7 equals to +4 this time. So when you transpose 7, that side is going to be -7. Then we have what? 4 minus 7 gives us what? -3. Now we need to choose one solution here. But now let us look the value of k. But you can see from here, and then we also have this point here, and you can see the value of y on this point is -7. Surely this one, it can be -3. It cannot be what? -11, because -11 cannot come before what? -7. So the final answer is k equals to -3. And then we are in 3.4 parallelogram. TDNS with n in the fourth quadrant is drawn. Calculate the coordinate of what? The coordinates of n. Alright, let me just remove this. So we're told that there is a parallelogram of T, D, and then N, which is on the fourth quadrant, maybe somewhere here. So it should form a what? A parallelogram. Let me just try to draw. This pen does not get drawn. You can see there is a parallelogram. So this one is going to be N. Now they say we should now calculate the coordinate of what? This N. So since a parallelogram, we know that the properties of parallelogram as well as the diagonals of parallelogram. So I'm just going to draw them like this, because they are going to help us to calculate the coordinates of n. Now We are saying the midpoint of Tn, you can say Tn is what? Is that diagonal equals to the midpoint of SD, SD, that is the another diagonal. They are equal in terms of the midpoint. They meet at this point here. The midpoint of Tn is equal to the midpoint of SD. If that is the case, then we're going to be using this formula here, and then we start with x. So we're going to say the x from this point n plus the value of x on this point, which is negative 5 over 2 equals to what? Equals to negative 3 is plus 0 divided by 2. The same applies with this one. This one is y. Then from there you simplify it using the value of x. Then the value of x is going to be negative equals to 2. And then on this side, the value of y equals to negative 5. Therefore, the coordinate of n is 2 is to negative 5. All right. All right. The question is still continuing. Let's see what we have now. 3.5. Triangle PRG is reflected about the y-axis to form triangle P prime R prime T prime. Calculate the size of R angle D R prime. Let's see what we have first on this triangle. Let's now identify this triangle PRD. PRD. So let me just extend a line here. Give us a line here. So you can see now we are having triangle PRD. All right. So they're saying that triangle is going to reflect across which line? Y-axis. And then if that is the case, then let us try to form a new triangle which was reflected. So, and then this point P is going to come this side. If we're going to have a P here, it's going to be P prime. And then this one, this R is going to come this side. So it's going to be R prime. All right. And then this point D is still going to be here, because even if we can just reflect it, it's going to be on that side. So we form a triangle again. So there is a new triangle here. There's a new triangle after reflecting. All right. Now, what is the question? We now need to calculate what? Need to calculate the size of R angle D R prime, meaning we need to calculate this angle here. All right, we need to calculate that angle. Now, how do we start to calculate that angle? Then we say from the scenario, we say PEFR is parallelogram. Where is PEFR? We can see that PEFR is a parallelogram. Why? Because we can see that PR is parallel to EF. And then what do they say about that? So since that is the case, we're saying angle R equals to theta is either here, which is 63,43 degrees, because the opposite angles of parallelogram, they are equal. Meaning, remember earlier on we have determined this angle here, it was 63,43. Then we are saying the opposite angles of parallelogram, they're equal. It's also 63 there. All right. And therefore we say R and R angle R prime D equals to 63.43 degrees. Why? Then the solution, the reason for that is angles opposite equal side. Remember, RD equals to D r prime, meaning the distance of these two sides are equal. So remember, this is an isosceles, and then you remember the base angles of isosceles, they are equal. So meaning this one and this one, they are equal, right? Then since we are now having what? Since we are now having two angles in a triangle, then it's going to be easy for us to calculate the third angle there. All right, now let's see. And now we can be able to calculate. So we're going to say r angle d r prime equals to what? 180 minus the sum of those two angles, which is 63,43 plus 63,43, the sum of angles in a triangle. Then after adding, subtracting from 180, then it gives us 53,13. That is the angle that we have to calculate. Now we are in question 3 of analytical geometry of 2022 question paper, which was written last month in November on the 16th. And then let's see what was the question. All right. Triangle TSK is drawn. The equation of ST is y equals to 1 over 2x plus 6, and ST cuts the x-axis at M. W is what? It's -4:4, lies on ST, and R lies on SK, such that WR is parallel to y-axis. YK cuts the x-axis at V and y-axis at P, which is 0 is to -4. KS produced cuts the x-axis at N. Now T angle SK equals to theta there. You can see this is theta there. And now let's see what are the questions. Calculate the gradient of what? The gradient of WP. Where is WP? WP is quite simple. We've got the coordinates, then it's quite easy for us to calculate what? The gradient. Now we write the correct formula for the gradient, you substitute the values correctly, you press your calculator, then you have the gradient, which is -2. Now they are saying show that WP is perpendicular to what? To ST. All right. Now remember, when you have to prove two lines they are perpendicular to each other, is when you multiply the gradient of those two lines, and if they give us -1, then it tells us that those two lines they are perpendicular to each other. All right. Now first we have to calculate what? The gradient of what? The gradient of ST, which is this line, ST. But where do we get the gradient? Since we don't have 2 points where we can now calculate the gradient. Remember, from the scenario, we're given what? We're given the equation of what? Of ST. And then from that equation, we can take out the gradient, which is half 1 over 2. And then we have 1 over 2. Therefore, the gradient of WP multiplied by gradient of ST is -2 multiplied by 1 over 2. When we multiply them together, they give us -1, -1. Therefore, ST is perpendicular to WP. All right. Let the question still continue. Let's see what we have now. Okay, we are now having a new question. They say if the equation of what? Of SK, where's SK? SK. If the equation of SK is given as what? As 5y plus 2x plus 60 equals to 0. Calculate the coordinate of S. They need the coordinate of S. Now let's see how best can we do that. Now remember, we need to rewrite this equation and then make y the subject of the formula. This is what we're having now. Y equals to -2 over 5x minus 12. That is the equation of SK. Now, remember, when you have to calculate the coordinates of this point S here, then you can see that is the point of intersection of these two lines of line ST and SK. And then remember, when you have to calculate the when we have to calculate the point of intersection where the two lines meet, then we have to equate the two equations in order to solve that point. Now we can see that we say the equation of what s the equation of sk equals to the equation of st. We equate them together, then we solve the value of x. Then you simplify it, and then now the value of x now is going to give us negative 20. So since we're having the value of x as negative 20, you can choose from any. You can choose the equation of st, you can choose the equation of sk, for you to be able to get the y corresponding value there. Then let's see. Then we have used the equation of st. So where you see x, we then going to be substituting with negative 20. And so this one is negative 20. Then press your calculator, it's negative 4. Therefore, the coordinates of s is negative 20 is to negative 4. So that's how you should now determine their coordinates. So you always should remember that point of intersection, you equate the two equations, you solve the value of x, you then choose any equation to determine the y corresponding value, and it will give you that point. All right, the question still continue. Let's see. We are having another equation. Another question is calculate the length of what? The length of WR. Where is WR? Here is WR. We need to calculate the what? We need to calculate the distance. Now, fortunate, we have the coordinate of now W, which is negative 4 is to 4. And then since this line is what? Is parallel to the y-axis, and therefore we can also say the coordinate of this r is what? Is negative 4 is to y. Negative 4 we can be able to know the value of x, we can be able to see is negative 4, but now we don't know the value of y. Remember, we should have two, we can have what? We must have two coordinates in order for us to calculate the distance. But now, let's see how best can we do that. Now, since we have what? We have only the x value there, which is negative 4, we don't have the y value. And then this point is on this line of sk. And then sk, remember, we have the equation of that line. It was given to us. Now, we're just going to take this point and substitute that equation, and then y equals to, and then where you see x, you just substitute with negative 4. Therefore, you multiply, then you simplify it, then give us y as negative 52, negative 52 over 5. So now we are having that the coordinates of r, which is negative 4, it is to negative 52 over 5. Now we can now calculate the distance. All right, now in order for you to get the distance of this point, these 2 points WR, you can say 4 minus negative 52 over 5, then it gives us how much? It's going to give us 72 over 5 units. So that's how you should now determine the distance. Or you can use the distance formula, the one that we know, the one that we normally use. So it's still going to give us what? It's still going to give us negative 72 over 5 units. All right. Okay. Now we are in 3.5. Calculate the size of angle theta there, which is this angle theta. Let us now calculate this angle theta. Let's see how best can we calculate that. Now first, we say the gradient of sk. Where is sk? The gradient of this line sk. Why do we need the gradient of this line sk? Because it's going to help us to determine the angle of this angle beta there. And then let's see. Then after calculating that, angle beta there is what? Is 158,19. Remember, if we have the gradient of this line, we are going to use tan beta equals to a negative or equals to the gradient of sk, which is negative 2/5. Thereafter, we get the reference angle, which is 21,5, 21,801 degrees. And therefore, the angle of beta is 158,19 degrees. All right. Now, since we can now calculate what m angle ns, which is this angle here. We need this angle here. Then we are going to say 180 minus 158,19. It's going to give us 21,80 degrees. All right. Now, so we are having this angle here. Then we say the gradient of st. The gradient of st. Then why do we need the gradient of st? St is going to help us to determine this angle here, and then we know that this angle and this angle, they are the same because vertical opposite angles, they are equal. Vertical opposite angles are equal. From there, what you do, and then we can call it a alpha there. See, they're giving it alpha. So we say tan alpha equals to the gradient of st, which is half. Then it's going to give us alpha as what? As 26,56 degrees. So meaning we're having this angle here. So now we can see this is a triangle. MNS is a triangle. So remember, in a triangle, when we add the two angles, then they're going to give us this angle as an exterior angle of a triangle. Hence we say M angle SR, we add the two, we add this angle plus this one, they give us the exterior angle, which is this angle that we are in need of. So that angle is going to give us 48,366 degrees. Therefore, that theta is going to give us 48,37 degrees. All right. All right, same scenario, same question. Same scenario, same diagram, but now we have the new question. 3.6, let L be a point in the third quadrant such that SWRL in that order forms a parallelogram. Calculate the area of what? Of SWRL. Now let's see. Let L be a point in the third quadrant such that S, W, R. So for this to form a parallelogram, surely it must be something like this. It must be something like this. So this point there is point L, and it gives us parallelogram. Right. Now we should now calculate the area of this SWR. All right. Now let's see how best can we calculate the area. Now first, what we have to do, we calculate the distance of SW. If we calculate the distance of SW, is going to give us 8 square root of 5, because remember we have calculated the coordinates of S, we have the coordinates of W, we can calculate the distance of SW. We also have to calculate the distance of SR, the distance of SR, because we've got the coordinate of S, we've got the coordinate of R, we can be able to calculate the distance, which is now 16 square root of 29 over 5. Then after counting the distance, why do we have to calculate those distance? Now remember, under trigonometry, when we are talking about the area rule, when you're talking about the area rule or calculating the area of a triangle, so what do we have to do here? We can see that one of the condition where we have to use or be able to calculate the area of a triangle using the area rule, we should have two sides. We must have given two sides, and then one angle which is between those two sides. All right. Now we can see that we have calculated this angle here, and then we have just determined the distance of these two lines. All right. Meaning we are now allowed to apply the area rule because we are now having two sides and one angle which is between those two sides. All right. Then that's why we have used this formula here. Area of triangle SWR, which is half equals to SW multiplied by SR sine theta. Then remember we have what sine theta there. We have sine theta which was for 48,37. Right. Now remember this is what it's a parallelogram, and so you should know that if in a parallelogram this triangle SWR is identical to this triangle SRL. So meaning this triangle and this triangle, they are the same. Alright, now that's why we said times 2, because the area of triangle SWR is equal to the area of triangle SRL. So hence we multiply that angle because it's twice. Then that angle give us what? Not angle, but the area. Say the area, it gives us a 230,14 square units. So now we have determined the area of SWRL. All right, now we are in question 4 from the question paper of 2019. Let's see what was the question and how best can we answer that question. Now it says in the diagram, a circle with a center M touches the x-axis at a what? At A, which is -1:0, and then y-axis at B, which is 0:1. A smaller circle centered at N, which is -1/2:3, passes through M and cuts the large circle at B and C. B and C is a diameter of a circle and a smaller circle. A tangent drawn to the smaller circle at C cuts the x-axis at D. Then we can see there's the diagram. Now the first question that we need to address, 4.1, it was saying determine the equation of a circle centered at M in the form of this. Now remember, for us to be able to calculate or to determine the percent, to determine the equation of a circle, we need the center and then the radius. And if you don't have the radius shown, you must be given what? A center and then 1 point on the circumference of that particular circle. Now let us see what we have here. So we can see that we are focusing on the bigger circle, and then the center of that bigger circle is this center M here. Now we can see that we don't have the center M. We don't have the center M. We don't have the radius. We only have 2 points on the circumference of that bigger circle. But now, what is going to happen? The center M is -1:1. How do you obtain that? Now remember, this line, which is x-axis, is acting as what? As the tangent to the bigger circle, because it is the tangent. It cuts the graph at this point. So since this is a tangent, meaning this is the center, and then surely, and if we draw a line from this center to the tangent, it's going to be perpendicular there, and then we are given the coordinates of A, and then the value of x there is -1. Therefore here it's also going to give us -1. The same applies with this line of y-axis. Is the tangent to the bigger circle, and then when you draw a line from the center of this bigger circle horizontal to this side, then remember they are going to be perpendicular to each other. Radius perpendicular to tangent. Always you should remember that. You know it from what? From Euclidean geometry, that a tangent and a radius, they are always perpendicular to each other. Therefore, and then here we are given the y value there, it was what? The y value was 1. Hence we say the coordinate of m are -1 is to 1. Right. Now, how do we obtain the radius there? Remember, from this point, from here to the center, you can see it's 1 unit. Because from here to there is 1 unit. The same from here to there is 1 unit. So the radius, it was what? 1 unit. Then we said, then we substitute the value of a. The value of a, remember, is negative. It's -1. So now the formula, it says negative. So negative multiplied by negative is equal to positive. Hence we have x plus 1. Y minus 1, because 1 is positive. So it's going to be y equals to 1. I mean y minus 1 equals to, what is the value of r? Is 1. So it's 1 squared. So 1 squared is equals to 1. So that is the equation of the bigger circle. Next question, 4.2. Calculate the coordinate of C. Coordinates of C. Let's see the coordinates of C. Next one. Let's see how do we calculate the coordinates of C. We say the midpoint of SB. The midpoint of SB is N. The midpoint of BC is N. And then the coordinates of N we are given, which is -0,5 is to 1,5. Or we can say -1/2 is to 3/2. So since the midpoint of BC is N, then we are going to use the method of getting the midpoint. Then we're going to say the midpoint of BC equals to XB plus XC over 2. And the same applies here. The midpoint of, for Y is midpoint of MBC equals to YB plus YC over 2. The second step, remember the midpoint of X for X value here is -1/2, which is -0,5 equals to what? XB is 0 plus XC is what we're in need of over 2. The same here for Y is 1/5 equals to 1 plus YC over 2. Then you cross multiply, you simplify. Then the value of X for XC equals to -1, and then YC equals to 2. And therefore, the coordinate of C is -1 is to 2. All right, the question is still continue. Let's see what we have here. Uh, 4.3, show that the equation of the tangent CD is this. Show that the equation of a tangent CD, where CD? This is CD. CD. So meaning we have to determine the equation of this line CD. And then this CD we can see is a tangent to a smaller circle. All right. Now first, we have to determine or calculate the gradient of what? The gradient of this NC or CN. The gradient of CN, which is the radius. All right. Now, after calculating the gradient of that line, it gives us -1. Now, because that this radius is perpendicular to the tangent, then we say the gradient of the radius multiplied by the gradient of the tangent, it must give us -1. And then we have determined the gradient of what? Of the radius. Then we are in need of the gradient of what? Of this tangent. Remember, for us to be able to determine the equation of a tangent, we need a gradient, we need a point. We have only this point, which is point C, but we don't have the gradient. But if we had the coordinates of this D, then it was will be easy for us to determine the gradient, and you just take any point, you calculate the equation. But now, since we have only this point C, you need to use the gradient of from this line, which is the radius of the smaller circle, and then now we simplify it. The gradient of the tangent equals to 1. Then we're going to use this point C. We're going to use this point C. Remember, you've determined point C. Then from there, we're going to substitute the values, and then we say y minus 2 equals to 1 is to x plus 1. Remember, these points are from point C. And then from there, you open a bracket with this positive 1 there. It's going to give us x plus 1 plus 2. Because we're going to transpose this negative 2 to the right, it's going to be positive. Then from there, you add, then it's going to give us y equals to x plus 3. But since they need it in this form, then we're going to transpose x that side. Then it's going to give us y minus x equals to 3. Four point four. Determine the value of t for which the line y equals to x plus t will not touch or cut the smaller circle. Now let's see how best can we answer this question. The tangent to a smaller circle is this one, where we have determined the equation, which is y equals to x plus 3. And then there is another one that we can draw here. And let me just make another tangent there. Is another tangent, which is y equals to x plus 1. Now, we should determine the value of t such that those two tangents, they must never touch that smaller circle, right? They will never touch or cut the smaller circle. Now, how do we do that? Meaning we need to transform these two equations such that they will never touch this smaller circle, right? They will never touch this smaller circle. Now, how do we do that? Now, first, the value of t here, it should be greater 3, because if it's less than 3, this line is going to come this side. So it's going to come here or there, only if t is less than 3. But now, for this line, for this line not to touch the smaller circle, the value of t here, it should be greater 3. Can be 4, 5, 6, up to positive infinity there, right? And then, or for the value of t for this one, for this equation here, and for this line not to touch the smaller circle, what is going to happen with the value of t here? And the value of t should be less than 1. Should be less than 1. So because if it's less than 1, it's going to shift in this direction. It's going to take this direction if t is less than 1. So that is the solution for that question. All right. And then another question. And the smaller circle centered at N is transformed such that the point C is translated along tangent to D. Calculate the coordinates of E, the new center of a smaller circle. So this one we say in the midpoint of Dn, because now we are going to have something like this. If you translate, we're going to have something like this. So this way, this is going to be the coordinate of what? The coordinate of E. And then you can see it gives us something like a triangle. This is triangle is 90 here. It's 90. Remember, this point is the center of a new circle, and then they translate along the tangent to D. So this line is still a tangent to this point there. So there's a circle there. So I just try to draw the circle with the center E there. Now we need to calculate the coordinate of this E. So what we're going to do, we're going to say the midpoint of DN. Where is the DN? So we can just draw a line to N there. The midpoint of this is equal to the midpoint of CE. The midpoint of CE. All right. They are equal in terms of the midpoint. Therefore, we first have to calculate the midpoint of what? DN. The midpoint of DN. Now remember that you can now determine the coordinate of D since we have got the equation of CD, and then we have the coordinate of N. Now it's going to be easy for you to calculate the midpoint. So the midpoint is going to be negative 7 over 4 is to 3 over 4. That is the midpoint. And when we say the midpoint of EN equals the midpoint of CE. And thereafter, if that is the case, since you've got the midpoint here, and then we also have the coordinate of what? We also have the coordinate of C, then we're going to use the midpoint procedure to calculate the coordinate of E. Then we start with X. We say X from this point E plus minus the value of, remember there is negative 1 there. So it's plus minus 1, so it's going to be minus over 2 equals to the midpoint, which is negative 7 over 4. The same here, the value of, you take the y value there, which is y, plus the y value there, which is 2, divided by 2 equals to the midpoint of this dn, which is 3 over 4. Then you multiply, you simplify it, give us x equals to negative 4 over 5, and then y equals to negative 1 over 2. Therefore, the coordinate of E is negative 5 over 2 and negative 1 over 2. Right? And now we are into question 4 of the paper 2020, paper 2 of 2020. Let's see what was the question. We say m negative 3 is to 4 is the center of the larger circle, and a point on the smaller circle having a center O, which is 0, is to 0. From N, which is negative 11, is to P. A tangent is drawn to touch this larger circle at T, with Tn is parallel to the y-axis. Nm is the tangent to a smaller circle at M, with MO as a diameter. 4.1, it says, determine the equation of a smaller circle. Where is smaller circle? We need the equation of a smaller circle. Now we say, remember, this smaller circle is centered at origin. So y, that's why we have x squared plus y squared equals to r squared. And now we need to calculate the r squared. So we are going to look for any point on the circumference. The point that we're having here is point M, which is negative 3 to 4. And we substitute negative 3 and 4, then the value of r squared is 25. Therefore, the equation of that particular smaller circle is x squared plus y squared equals to 25. 4.2, determine the equation of a circle centered M in the form of this. Now, the bigger circle, so we have the center, which is negative 3 to 4. But now the problem is that we cannot be able to determine what the radius, which is r. But now we need a point on the circumference of a bigger circle. But now, since Tm is parallel to Tn, are parallel to each other. You can see that. because this is the center, and then from center to this tangent, because TN acts as a tangent, so it's going to be a line like this, so it's perpendicular to each other here. And then if that is the case, the coordinates of what? The coordinates of T is -11 is to what? Is to 4. So since we've got the coordinates of what? Of T, we can be able to determine what? The radius. So from this point here, which is -3, and then here is what? It's -11. So we can calculate the distance there, which is what? Is 8. So it's going to be -3. Negative is to -11 equals to 8. You can also use what? The distance formula there is going to give us +8. It's going to give us +8. So since we've got the radius, then we just substitute the values. The value of A is -3, then here is going to be +3. And the value of B is +4, is going to be -4 here. Then we substitute the value of R, which is 8 squared. Then the equation is going to give us this, which is 64. Determine the equation of NM in the form of this. NM, you need the equation of this. Now we can see that NM is the tangent to a smaller circle. Then now we first calculate the what? The gradient of OM, which is -4/3. Then we know that the gradient of OM multiplied by the gradient of MN equals to -1 because they are perpendicular to each other, those lines. And then since we have determined the gradient of OM, which is -4/3, then we can determine the gradient of NM, because for us to be able to determine the equation of NM, we need a gradient. Therefore, the gradient of NM equals to 3/4. And then we can take this point here, which is point M, and the gradient will come to determine what? The equation. Then from there you substitute the values. The value of y1 there is -4, you can see. Then this one is going to be positive. Then you open your bracket with this 3/4, it's going to give us 3/4x plus 9/4. Then this -4, we transpose it, it's going to be positive. Then when we add them together, it gives us y equals to 3/4x plus 25/4. So that is the equation of NM. 4.4, calculate the length of SN. The length of S is SN. S, we need the length of SN here. So we have point N, and we can now be able to calculate that value of P. Why? Because you can see this point N, we have determined the equation of that line, and where we see point N, and then we can just substitute this point in that equation. And then after doing that, when you simplify it, after pressing your calculator, it's going to give us the value of P as -2. Now we are now having what? The coordinates of what? N, which is -11 is to -2. Now we can determine the coordinate of S. If we can check the coordinate of S from this smaller circle, just you reflect this point here, you can see, and this point. So the coordinates of this M is the same as this one, but now it's going to differ in terms of the sign, because now in this quadrant, fourth quadrant, the value of what? The value of y is going to be positive, negative. The value of x is going to be positive. So you just have to change, but the coordinates are the same. You just reflect this point here to this side, which is 3:4. So it will differ in terms of the sign only. So since we're having the 2 points, which is n and s, we can now use the distance formula to calculate the distance of Sn, which is 10 square root of what? 10 square root of 2. 10 square root of 2. 4.5 if another circle with a center B, which is -2, is to 5. And the radius K touches the circle at center at M. Determine the value of K correct to 1 decimal place. We have the center, which is -2:5. That is the center of another circle that touches the circle centered M. So there is a circle there somewhere here, the center of the circle, and this circle, it touches the bigger one. We don't know where, but now we then calculate the distance from the center M to the center B. So that distance gives us square root of 2 units. Thereafter, we say the radius of the circle of centered at M, it was equals to 8 units. Remember the radius of a bigger circle, it was 8 units, right? It was 8 units. So we are going to say the radius of a bigger circle minus the distance, which is square root of 2. Then it's going, the same applies here. We're going to say 8 plus square root of 2, because we don't know whether the circle is outside or inside the circle. It's outside of the bigger circle or it's inside the bigger circle. All right. Therefore, the answer is going to give us 6,6, and then this one is going to be 9,4, because the instruction was saying to us we should write 1 decimal place. So it's 6,6, and this one is going to be 9,4. All right. Thank you very much for being with me on this very interesting lesson. I hope everything that we have discussed is going to make sense to you and is going to help you in order to prepare for this coming exam for mathematics paper 2. And then before I can leave, I just want to give you or leave you with these words that says, study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you'll probably be late, right? So please use time when you have time. Study, don't postpone any study. You should start as soon as possible. Let us prepare thoroughly for this coming exam for paper 2. Remember, we have to rewrite that paper. So let us make sure that we, for the last time now, we prepare ourselves thoroughly, and then we are ready for that paper. All right. Thank you very much. Have a nice day. Bye.